Get off that silly Xbox, please. Isaac, get ready for school. Come on, boys.
Yes, Mom.
99% of the scientific community said it was not possible. And I was seen as somewhere between a dreamer and a clown.
Not far from Sydney is the picturesque country town of Camden. It was here that Professor Graeme Clark began what was to be a lifelong quest, one which transformed people's lives and opened up new frontiers in science and medicine. His vision was sound for the millions of people who could not hear. The development of the bionic ear or cochlear implant would not be an easy journey and demanded courage, determination, and an insatiable thirst for knowledge, traits that were apparent very early in Graeme's life.
I don't remember too much after I was born till I was about 3 or 4, but my parents told me I was a bit of a handful. They told me that I used to wake up early, and I've got a photo of them taking me for a walk. Poor parents. I had a lot of energy, and that attitude continued as I grew up till my sister came along and then my brother.
Graeme was 3 years older than I was, and he was always the big brother, and there was always a lot of activity going on around Graeme.
As I grew up, I was always saying to Mother, what can I do now? And she'd find things for me to do, and then I'd say the same again. So she did have a hyperactive child on her hands.
I think that's what I remember most. That I actually didn't walk till I was 2 because I didn't need to. He provided all the energy in the family.
That energy found many outlets. Growing up in this small country town, the young Graeme was free to wander, riding his bike for miles, exploring the countryside he loved. There was also sport and cubs and getting up to tricks with the kids next door.
And of course they did a famous trick with me where they dug a great big hole in the ground and put mud in it and then thought that I wouldn't know what was going on, camouflaged it. No, I wouldn't know, even though I was watching it for days. And because I wouldn't walk over it, they actually pulled me over it. And what a surprise I had.
As a young boy, Graeme read widely and was inspired by the story of Louis Pasteur and also Madame Curie. By the age of 10, he'd already decided he'd be an ear doctor to help deaf people like his father, Colin, pharmacist and optometrist for the local community.
In the pharmacy, I would love to experiment with all the pharmaceuticals that he had, make smells, surprise people with the various potents that I had been able to create, and worked with the chemist's material and was known by the shop girls as the Bunsen burner boy who had come home from school. I learned too at an early age that people did want certain things like contraceptives and others, and they wouldn't always speak it in a loud enough voice for Dad, so he'd ask them to speak up loudly so all the people in the shop could hear, and they were embarrassed. And I tried to save him the embarrassment by going and saying, I'll get that for you, and knew where these things were. But I don't think I could have wished for better mother or father. They both had different talents. They both interacted in different ways. My mother was the creative person. She was a very gifted pianist, could sight read at a young age, and was an artist. She was in the Sydney art group and had scholarships. And so I inherited some of those artistic, creative talents, I think, from Mum. My father was much more the common sense, practical person, ran a very good pharmacy. He was always very wise, not that my mother wasn't. She had a more intuitive wisdom. My father had a more practical wisdom. But combined, they were great parents. And I think we as children realised that.
Yes, I can remember my father saying, never try and cheat the tax man. So I don't. Are you listening? Yes, he always brought us up to do the honourable thing, and he certainly treated us all well as his family. Yes, no, he was a good man, but so was Mum. And I remember Dad saying, when Mum died, you would describe your mother as pure in heart, and I thought that was a really lovely way of expressing what he felt about her. But he was equally totally honourable. Yes, no, they were great people.
Brother was good because he was 10 years younger than me, and so in a way I brought him up almost like a father. He sadly died some years ago, but it was really lovely having both a brother and a sister.
Bruce was very smart. He was very passionate about sport. He did very well at school when he came back to the local high school. He was rather a homebody, Bruce. But Bruce had an amazing compassion. And he had the ability to care for everybody. He was a really beautiful person. Mm.
In 1946, when Graeme finished primary school, Camden did not yet have a high school, so it was off to Sydney Boys High, spending weeknights with his grandparents and then home for the weekend, a 130-kilometre round trip. The following year, he began boarding at Scots College, where his sporting ability was soon noticed. School terms were busy with rugby, cricket, cadets and study, and Graeme made the most of his holidays back in Camden.
For me to be in a country town and free with parents who were guiding me to do different things was a really wonderful opportunity.
Graeme used his father's glass-blowing equipment to make his own testing materials. He set up a laboratory at home and experimented with plants, developing his dissection skills whenever and wherever possible.
Yes, I did some slightly unusual things, but they weren't illegal, I might say, at that stage. I did simple experiments in my mother's laundry to try to look at the biological side of things. And so when I went to medicine, it was exciting to learn about sexual and asexual reproduction in flowers. Turned me on. And then we did all sorts of things, dissect stingrays and so on. Then, of course, to do anatomy in our second year and dissect the human body, that was very stimulating.
At the University of Sydney, Graeme was already heading down what almost seemed a predestined path.
My real love was function and physiology. I was starting to really get to love that, and in my third year of medicine I was so taken with it that I took my textbook away on holidays and finished up with a first-class honours result and an offer of doing research.
That same year, Graeme discovered another love.
Well, I was 15 and I was at MLC Burwood with Robin, his sister, and she asked me to go up for the weekend to Camden, where they lived in the country. And so I went and another friend.
They got off the train at Campbelltown, and I two pretty MLC girls were on the train, and I took notice.
And I remember Graeme walking along the platform at Campbelltown station in a brown sports coat and slightly wavy hair and a nice smile on his face.
Then I went in the afternoon to give them a little bit of entertainment, took them out to the local golf club.
And that was quite a bit of fun. I remember him saying, oh, what a terrible shot he'd done, and I thought it was pretty good.
They had never played golf, and I thought I was pretty good. And I gave them some instruction, and I thought it was really quite nice being able to hold Margaret from behind and show her how to play these shots.
Yes, that night I remember they had a clock, the church clock. It struck every quarter of an hour, and I had trouble getting to sleep. Maybe it was excitement too, I don't know.
But it was early days. They were both young and needed to focus on their studies. Graeme began his clinical training, working with patients in the wards. He loved this part of it so much that he spent much of his holidays gaining experience with Dr. Crookson, a local doctor and surgeon.
He was the epitome of the old-fashioned doctor who did everything. And he took me under his wing. He'd let me go and watch and maybe even do a little assisting when he did gastrectomies, taking out the stomach of some of the locals, and all sorts of operations. Let me take blood from some of his patients.
Graeme's passion for all aspects of medicine saw him top his final year at Sydney University. Over the next few years, Graeme crammed in a range of surgical experience, with residencies at Sydney's Royal Prince Alfred and Royal North Shore hospitals. He was also seconded to the busy casualty department of the Wollongong Hospital. Here, Dr. Clark operated on patient Clark with anaesthetist Clark in the Clark Theatre. Coincidences seemed to come Graeme's way. At RPA, he was appointed Registrar of Brain Surgery, and then of ear, nose and throat, both areas intrinsic to his future work. He had also, by chance, met up again with Margaret Burtonshaw, whom he had most definitely not forgotten over the last 5 years.
We got together again when I was over the problems of working like a slave as a resident at Prince Alfred and the North Shore hospitals. And then I met Margaret again after our youthful friendship and knew that she was the right one. She was the nicest girl I'd ever met and still is.
I went round to visit Robin, who was in a little flat in my suburb. She had done pharmacy, and I hadn't seen her for a while. I thought, I'll go round and see Robin. And when I was there, Graeme visited. And, well, from that time, we found we had a lot to talk about. And it wasn't, yes, that was November of a year, and we were engaged by the next April.
On the 27th of December 1961, Graeme and Margaret married. 3 days later, they were on their way to the UK.
We went to England, as most did those days, to get postgraduate training in surgery at the Royal National Throat, Nose and Ear Hospital and the Royal College of Surgeons of England and Edinburgh. So I'm a fellow of the Royal College of Surgeons in general surgery, and there's also in ear, nose and throat surgery.
Returning to Australia, Graeme and Margaret were now expecting their first child and needed a stable income.
So my father had a friend who was a pharmacist and then an ENT specialist here in Melbourne, and he was looking for a partner. So I came to Melbourne as the surgeon in the partnership, and then my living that way. And that's how we got back to Melbourne, and I was in that private practice for 3 years.
Graeme was frustrated at being unable to help profoundly deaf patients and believed there had to be a way.
And I took out the latest paper to read, to be up to date, and saw this article by Blair Simmons where he'd actually stimulated one profoundly deaf person who had some hearing sensations but couldn't get speech understanding. And I said there and then, it lit the fire in the belly, a bushfire, that this is really what I wanted to do. I wanted to be, for better or worse, I wanted to help people who were profoundly deaf. For some reason, that was what I'd been sort of working towards, unbeknownst to me sometimes, and that's where I really found a fit.
So it was arranged. Graeme was offered a research position at Sydney University. The family made the move late in 1966. Graeme, Margaret, and their 2 daughters, Sonia, not quite 3, and Cecily, just 16 months old.
When I left private practice to go to Sydney University to do what I believed to the important basic neurophysiological research, there was no likelihood necessarily that it would work, because 99% of the people, the scientists of the day, said it would not work. And I was seen as foolish and other things. I was called that clown Clark, and there were comments made that it would be as successful as putting a light bulb in the backside and turning the electricity on. So that was the attitude. And so I left in that climate to give up my partnership and become a poor PhD student.
Yes, we had a car that packed up when we were thinking we'd take a trip back to Melbourne and visit people in Melbourne, and it stopped and never went again. So we left it at Gundagai Tip.
We didn't have money to buy another second-hand car, so I had to travel everywhere by public transport or goodwill of friends. But it turned out to be a blessing, because there's nothing like standing at a bus stop, waiting for a bus, to think. And I learned at the University of Sydney to think. And that's the difference between being a surgeon and a research scientist. You have lots of mental challenges that you've got to think through.
The trick with cochlear implants is not getting people to hear. That's actually easy. You can put a wire in the ear and you can send a current down it and people will hear something. The trick is getting them to hear something that's useful to them. And what's useful is hearing speech in particular for communication and making that as clear as possible.
Graeme's thesis focused on exactly this problem: how to enable speech recognition through electrical stimulation. He knew that 20,000 nerve endings in the brain are involved in normal hearing. Through his research, he worked out how to electrically stimulate the important nerve endings using just 10 or so electrodes. To Graeme, it made sense, but he had to turn that theory into reality. There was a lot of work still to be done, and his 3-year term at Sydney University was now over. As one door closed, another opened. In 1969, the University of Melbourne was looking to appoint a foundation professor of an entirely new department.
The chair of otolaryngology was the first in this country, and it was at a time when ear, nose and throat work was not necessarily seen as elite academically. It used to be thought of as taking out tonsils and snotty noses and so on. It's, of course, times have changed and it's one of the high flyers now. But at that stage, the University of Melbourne, the academic side, was more into the traditional subjects like ancient history and mathematics, and they didn't even see a place for medicine, but certainly not otolaryngology.
This break from tradition and Graeme's appointment as chair produced a groundswell of criticism and ridicule directed at Graeme by many of his peers.
You know, he got told by many people during that time this was a lot of nonsense, and his colleagues were not all that supportive. I know that they've turned around now quite a lot, but, you know, the fact is back then colleagues, both scientific colleagues and ENT colleagues, were not necessarily supportive. But he had that perseverance to say, well, this is what I'm doing with my life, and I'll keep it going.
Graeme is a person that feels things very, very deeply. He's not able to just say, oh, I can brush that aside. I'm sure he would have felt it very deeply. But I think he just had the courage of his convictions and faith that he needed to go on.
Well, when there's criticism and difficulty, we can always pray about it, and that was very important, really. And Graeme prayed constantly, really. And in the church, we went to church, and that was always a help. And I think just believing that God could help you and guide you.
My Christian experience has been hard-earned and tried to live it in the real world. And developing the bionic ear was as hard a part of the real world as I could have experienced. I can assure you it was one of the most demanding experiences of my life.
well, we'd talk about it. He was always willing to talk. You know, that's important. So I could be a sounding board. And that helps. Some men just bottle up, and then it's hard to help them. So I think he was saved by that.
I don't think it impacted our lives when we were very young very much, because Mum was such a constant, steady support, not only to Dad but certainly to us.
Margaret was a young schoolgirl friend and a great supporter, a great person, and I have lots to owe her for her tremendous support that she's given in many ways.
Yeah, that saying about behind a successful man is a strong woman couldn't be more true when you think about them.
Although the hours were long, Graeme was able to enjoy family life, especially weekends. The family loved it at home in Eltham. It was a haven for Graeme and Margaret. There was plenty to do, finishing off the house they'd built, setting up the garden, and simply enjoying every aspect of their 1 acre property. For the children, there was much to do, the perfect place to burn off an abundance of energy. Graeme's parents would often come down from Sydney, and when Robin and Bruce arrived with their families, it was quite a gathering. Back at work in Melbourne, pressure for funding continued.
When I took the chair, I was told I had to raise my own money, and I got $6,000 a year from the faculty, and the rest was up to me. And I could see it was going to cost some hundreds of thousands of dollars to develop the first prototype electronics, and I just didn't have that sort of money.
But Graeme had a lot of support from people who could either help him directly, and I'm thinking of, for example, the Murdoch family.
That generosity from private individuals and foundations enabled Graeme to put together a small team and begin the essential research, and eventually even buy a computer.
When you think about it now, we take so much for granted, for sure. We needed to use computers to analyse the brain responses that we got from physiology. We needed computers to analyse the speech signals that we were getting and how to manipulate those. Now, what we don't realise that the memory for these computers and computing was 4K, 4,000 bytes. Nowadays, we're talking in terms of hundreds of thousands, megabytes, millions.
There was an extraordinary team spirit there, and people came from different disciplines. You know, I mentioned BMed science students, psychologists. I had a background in physics and developing expertise in physiology. In fact, my PhD ended up being in auditory neurophysiology. Mathematicians, engineers, but all of these were important. I mean, the psychologists, the behavioural people were interested in doing behavioural experiments with animals to see if electrical stimulation of their nerves could distinguish between sounds of high-pitched and low-pitch and so on, all necessary conditions for ultimately developing a bionic ear.
The group that was doing the funding for the research really had expert consultants that would go and talk to, and so the view from them was very negative.
So when it came to Graeme applying to the National Health and Medical Research Council for grants, and I don't know the reasons, but he didn't get the support that he probably deserved, because I'm not sure that everyone were quite thinking on the same wavelength as Graeme.
And so it was always thumbs down from them, no money from them.
Graeme managed to generate some funds speaking to community service clubs such as the Apex Club of Melbourne.
And it got on to the ABC News that they'd raised $1,000. Sufficient interest then. And who should be watching the opposition's news but Sir Reginald Ansett? He was just setting up Channel O, as it was called then, and he was keeping his eye on what the others were doing. And so he saw that, and a flight went on. He thought, that's really what I need for a telethon for Channel O.
But for Channel O, as it was then, and Reg Ansett to say, we'll run a telethon for you over a fixed period, and my memory is probably 6 hours or something like that, just for one project within one department, it's quite remarkable.
Tina was here, and we're here to take your call. So what about anyone from Traralgon, ring Coral on 234 0011 and have a chat to your favourite weather girl, okay?
And I'd love to take a call too. Please do phone in.
Your help is needed to assist in rehabilitating people with a permanent hearing loss. Rehabilitation costs money, and that's what this telethon is all about.
And it brought in some money just to start us rolling. And, you know, this was riches to me. $10,000, $20,000 was just unbelievable.
We thought they were so exciting, like a concert. You know, the applause sign would flash and we'd be screaming out. So that was really exciting.
It was sufficiently of interest to then for Reg to have a second major telethon in 74, another one in 75 and 76. But that was enough to get the electronics developed and some staff like Jim Patrick and others to develop the first prototype to see if it would work.
Electrical engineering here at University of Melbourne was very lucky to have a David Dewhurst, who actually started biomedical engineering in the late 70s. 77 he started up the course, and Melbourne was the first university to offer biomedical engineering.
The Department of Electrical Engineering, through David Dewhurst, was the first time really that the Australian university had actually had contact with biology and medicine. It was groundbreaking stuff.
And David Dewhurst started working with Graeme Clark with a few students of his.
David had two very good students, particularly Ian Forster, who was doing a PhD in engineering, and David had him working over with me, and we both supervised Ian, and then there were other linkages developed.
He had put a lot of effort into gathering together PhD students mostly, but with skills in the areas that he saw were going to be needed to really work on all the aspects of the cochlear implant design. So we had, I don't know, a dozen PhD students, and then of course access to their supervisors in other faculties. So here one was in the medical faculty in otolaryngology, but actually with connections through to psychology, mechanical engineering, electrical engineering. All this is these really very skillful people who then of course contributed through their students. It was a wonderful group.
I changed the Department of Otolaryngology to become virtually an engineering cum biology laboratory. In fact, the area, for example, where I used to set aside to wash wax out of people's ears became an electronics lab.
Oh, well, there was a huge spirit in the place. There really was. I mean, some of the experiments would go through, through the night to the next morning. And if it had to be done, people were certainly, that's just how it worked. And he was there contributing to the effort in doing that as well. So, yeah, the mood overall was really good.
And at one stage, the Department of Otolaryngology for ENT was the second largest purchaser of electronic parts in the whole of the University of Melbourne. I think people must have wondered what on earth I was doing.
Always a big picture person, Graeme didn't confine his thinking to just the technology. In 1974, he established a postgraduate audiology school and became lecturer and chief examiner.
Graeme knew that right from the start. He needed the engineers, audiology, psychologists, the whole group. He tried to get good people together, covering all the disciplines, and he listened to them all. He just didn't sit there and say, well, I'm the boss, we're doing it this way. He would listen to that group of fairly young people and act on that. And that was so important. That's what really got it together.
He sought knowledge in all areas he considered would contribute to the project's success. He and the family went to England for 5 months, where he studied speech science at Keele University.
This was a critical step in my career to go to England. It was right at the stage I was getting money from the telethon, was meant to turn up to the telethons to help raise the funds, but knew that if I didn't learn more about speech understanding, then it would not be easy to do whatever was needed if the cochlear implant or bionic ear was to work.
His experiments at Keele identified what were the most important speech frequencies and their intensities associated with vowels and consonants, the basics of speech. Back in Melbourne, work continued on the advanced electronics of the implant.
It was just at the right time when these things were becoming available and we were able to harness those and use it. It was told to me it was beyond the capabilities of silicon chip work to put such a complex device in a human being.
We just have been very lucky all the way through. I mean, the chip that with Ian and I, if we tried to do that 2 years before, we couldn't have. That technology wasn't available.
It was done too against a lot of perplexity on the part of Australian industry. Can we do it? And we did.
With the technology now well in hand, Graeme turned his attention to selecting a suitable person for the first implant.
At first, when I asked for patients, no one came forward because they were all being told, don't go and see Clark and it won't work.
Some people, however, were not deterred.
My recollections for Rod, I mean, I talked to him a lot over the time. Like, he was in his mid-40s, had a car accident, went profoundly deaf really overnight, had teenage children and a wife that he only could communicate with when they wrote to him, and that really frustrated him, and so he was determined to do something.
Good morning, Rod. Good morning.
Good morning.
Yes.
How are you?
How are you?
Oh, not too bad, thanks.
How old are you? How old are you?
I'm
Are you
sorry.
how old? Your age. Your age? How old are you?
Oh, getting too old.
For years, Graeme had been planning the surgery technique, but in 1977, one step still eluded him. How could he safely guide a bundle of wires into the cochlea, a spiral that narrowed and tightened as it neared the hearing nerves? He mulled over this problem while sitting on the beach at Minamurra, near Kiama.
And I picked up shells, and they were similar in shape to the spiral of the human cochlea. And I experimented with grass blades, dune grasses, and little flexible twigs, and found a fairly simple principle, that it's very flexible at the tip, stiffer at the base, that it would go in around that spiral and not bind on the outside as these other electrodes were doing. So I thought, that's it. I cut short our holiday a little bit, and we came back to Melbourne, and that principle worked and it's really been a fundamental principle that's been used in all of the cochlear implant electrode arrays since.
On the 1st of August 1978, Graeme took a deep breath and began operating on Rod Saunders. He was assisted by Dr. Brian Pyman in a mammoth 9-hour operation. Today it's fairly standard and over and done with in just a couple of hours. After a month and 2 false starts due to technical problems, Rod was successfully switched on.
At first we didn't know what people would hear, and so we played the rhythm and the intonation of, we thought, a song that he would know. And we thought, well, the first one would be God Save the Queen. So anyway, Rod was playing God Save the Queen, and before we knew where we were, Rod had stood to attention, as it was the custom, pulled all the leads out of the equipment, and so we have no recording.
Rod heard sound, but speech had to be worked on. Over the next few months, Graeme's knowledge of speech science proved its worth.
We worked out how to process speech reasonably well by the simple clue given by Rod Saunders that when we stimulated different electrodes in his inner ear, he heard a vowel sound. It wasn't just heard as pitch or timbre, as we call it, but it was a vowel, and that put the clue together to break speech down into these special resonances called formants, and we did that for Rod, and at the end of 78 we played him our first speech test, and my audiologist, I asked if she'd give him the absolute standard test, and she wasn't keen to do it because at that stage she didn't think it would work. Anyway, I managed to encourage her to do it.
Bale.
Bile.
Male.
Mile.
Good.
Just for fun.
We're going to go to here. I've got a clue.
Raw.
Raw. No, I don't see it.
And I was so overcome with emotion of joy. I think it was the only second time I went into the next door lab and I simply burst into tears of joy.
Rod Saunders was undeniable proof that the bionic ear worked, and the Australian government took notice.
Malcolm Fraser and his cabinet realised that Australia was not earning enough money from industry and our intellectual contributions, and it was put forward by his minister, Ian McPhee, that there should be a special program to encourage science in this country to develop things that are helpful for industry. And they set up this public interest grant scheme.
It didn't take long to be convinced by Graeme that it was the absolutely most wonderful thing that could be done, not just for those with hearing impairment, but for Australian industry as well. It should not be another project that just fell by the wayside.
And it was fortunate that during that period of time, discussions with government, meeting their representatives and a very careful analysis, that they finally agreed in January 1979 to fund it, but only after we'd operated on Rod Saunders and shown that it was possible.
This was a crucial time for the development of Australian industry and, of course, the skills that go with it. Too many research and development projects had not been undertaken, too many Australian inventions had languished and had either not ever been developed or had been developed by commercial interests overseas. So here we had the opportunity.
And the Department of Productivity was looking for a commercial partner for the university project, and they found Nucleus, which was the company that was a parent company of Telectronics, a pacemaker company, and Sonics, an ultrasound company, and a number of other biomedical companies. And so they were interested in developing bionic ear, and they actually had all the technology which we needed to do it, because they were already into implantable devices, which is the really, really hard part.
The government established a public interest grant with funding spread over 4 phases. All of these were conditional on specific targets that pushed both the science and the engineering to new levels.
So that was first of all to do a market survey and develop the development cost plan with the Nucleus group, with Telectronics, and down here we're implanting 2 more subjects, and so that happened in 1979.
Also in Melbourne, intensive work was underway to improve the speech processor.
Well, Ian Forster was the guy who was the original electrical engineer, whose photograph that you can see with the chip. Then Peter Seligman joined us after Ian went off to Switzerland, and Peter was very interested in how we could turn this computer into something that the patients could wear.
So you need, for a cochlear implant device, you need an external as well as the internal device that takes the sound and processes it and sends it into the internal device. And Peter was the first one he came in with the mission, I suppose, to bring that down from a whole computer down to a wearable device.
They were building a box that was about the size of a TV set, and the idea was that the patient would sit in a room next to his speech processor, and people would sort of hold a microphone and be able to talk to him. And I could see that you could do this in a much simpler way. So instead of doing the job I was employed to do, I started sneaking off and doing my own thing and building a much simpler speech processor. So I built something which is about the size of a binoculars case.
And he was able to achieve that in, would have been 80 or 81, around that time when I just started. And we thought that was a great achievement, but there was a whole big box, but it was at least could be carried around by the two patients we had at that time.
The government support back in 1981, phase 2 of this project, which was to build the device, and so they paid the money to do that, and that was 1.6 million. Then the next thing, after we had the proof of concept with 6 patients in Melbourne, was to take that to the US as the first marketplace, which is identified by the market survey. And that was going to cost a lot of money. And so the government then came to the party with another grant, another 2.3 million, which was to actually fund the conduct of a clinical trial in the US.
You had a very serious, very committed, very knowledgeable group of people working in the area who understood the physiology, understood the psychology as well, understood the electronics, understood all the elements putting it together. So I think I was really very confident that they would make it, and that because of the significance of what they were doing, and because there was no direct comparison, that they would be likely to have that international impact.
Well, I know they got back, I think it was $20 million in terms of royalty payments back in the days when the license agreement was there. I haven't done the sums, but I think they're a long way ahead.
Unlike some issues, other issues that I raised, I didn't have to argue all that hard with my colleagues, because it was really self-evident. It was, as we say these days, a no-brainer.
The implant now is it's approved in most markets for severe to profound hearing loss, because it does much more now than it did at the beginning. At the beginning it just was a supplement to lip reading, it helped lip read. Now the average person can use a telephone.
I believe those ideas can be repeated, and we have an example of how it can be done. We can copy what was excellent in that environment, the collaboration, the multidisciplinarity that underlies all of this success in a way, and I believe it can be done again. And to some extent, it's that belief and that example that Graeme gave that gave us the vision also to work on a bionic eye.
When I first heard about the project, I thought, oh wow, this has got a long way to go. I really had absolutely no idea that in 3 years we would have a product that was, safe and reliable and marketable, and that within 4 years we would be selling that in the United States. That was from 1979 to 1983. That was just an amazing amount of progress.
If you didn't have Graeme and his persistence and these other qualities, gee, I just don't know whether it could have come together.
It's been wonderful. We've got hundreds of thousands of patients, of people who can hear who previously couldn't hear or had lost their hearing.
And as the world economy develops, I mean, it's millions of people. It will be millions of people that will eventually be helped by cochlear implants in particular.
A long way for the first dreams, Graeme's first dreams, are delivered and then some.
It is the reward for all the blood, sweat and tears. And there was a lot of challenges, there was a lot of angst, a lot of hardship, but now when I look back and I see these children's lives in particular changed, I feel so grateful.
It's amazing to think of that this thing worked, and that even when it worked we couldn't imagine the difference it would make and how it would help so many people. It's a miracle, really.
I think my brother's marvellous, but I think in life we're all equal. And we all have a different journey, and Graeme was given gifts that were pretty unusual. He was given Margaret, and he's been given a good, wonderful family. So if you're given a lot, you need to give a lot back. That's what I see. To much is given, much shall be expected, and I think that's what he's done.
Family tell me I must slow down, and I owe it to them to slow down. And honestly, I do try hard to slow down, but I owe a debt to them as well. So there's 10 grandchildren, 5 children and their spouses, and I like that too. They're special.
"30 years has changed the world. A small group from Melbourne that had to be heard. Don't try, you crazy fools. It cannot work, it's against all the rules. But armed with the brains are Peter and James and Graham's persistence to guide us. We forged ahead where they feared to tread, and showed that the dream could inspire us. We had one dream, that children